Hi, everyone. My name is Emil. I'm going to give a little update on layout. Basically, what we've been doing since we last spoke 6 months ago in Mountain View, what we're working on right now, and what the future might hold. Before I get into that, though, I want to take a few moments and talk a little bit about the layout team. The layout team is one of the feature or sub-teams that, that Doug started talking about a little earlier. And as you can see, we now have a total of 1 of them, and hopefully it will stay that way. So one of the key driving factors behind the organization into sub-teams is to encourage long-term ownership of the code. So over the last couple of years, we've had more of an ad hoc model where people jump back and forth and worked on whatever they felt like working on, or more on a project basis. That model served us very, very well for many years. However, it's hard to encourage long-term sustainability that way because no one was really feeling ownership and took the time and effort to invest in infrastructure and making sure that we pay down our technical debt and had a healthy code base. Now, the layout team is one of the larger of all the sub-teams, if not the largest, which is hardly surprising given that Blink is predominantly a layout engine, and a layout engine sort of needs layout, at least a little bit. So over the last couple of months, about 25% of all commits in core has touched layout in one way or another. Looking historically, this number has fluctuated between about 20 to 35%, so it's pretty stable. Perhaps more tellingly, though, is that almost 40% of all the Blink committers routinely commit code to the layout part of the system. Now, this includes contributors from all major organizations contributing to Blink, be it Google, Intel, Samsung, Opera, and many, many others, as well as a number of individual contributors. So it's really encouraging to see so many people participate in this space, and many obviously really care about it. So now to get back to some of the things we have been working on for the last few months. Obviously, I can't talk about everything we've done, or you'll be listening to me all day, and I don't think anyone wants that. Instead, I'm going to highlight a few of the more important or highest impact things we worked on, starting with things that improve web compat and new capabilities. The first thing I want to highlight is the region-based multi-column support that our friends at Opera and predominantly Martin has been working on. It recently landed and is enabled as an experimental web feature now. Not only does it fix a ton of problems with the old implementation, it's also a much, much cleaner implementation that's easier to maintain and work on, and not nearly as scary as the old one. So that is a major accomplishment, and I'm really happy that we are on the track to ship that. Similarly, we've recently been updating our Flexbox implementation. This has mostly been Christian's doing. We've been basically taking our existing implementation and bringing it back up to the spec, because the spec has moved quite a bit since we last worked on it, and also to make sure that we remain compatible with the other major browsers. Like, this is one of the flagship features for the modern web, and we want to make sure that we don't make the lives for developer harder by having implementation that's not compatible with the other browsers. Similarly, we've been doing a lot of work in the text space. We've recently added better support for Myanmar and Gothic scripts, which is huge because this is scripts that are pretty hard to get right, and getting the fallback fonts correctly for that. And on that note, we also added support for emoji, which I'm sure all of you are very familiar with. Shockingly, we got way more press on that than on the Gothic scripts. I have no idea why. And finally, on text, through the work of mostly Koji and Dominic, we vastly improved their support for vertical text. Not only is the new implementation much more capable and can render vertical text way more beautiful and better aligned than before, it's also significantly faster, and shockingly also requires way less code. So many of these things are examples of new capabilities that we do through a better, clearer design, paying down technical debt, and still getting a performance improvement. And when you can get all three, that's an obvious win for everyone. What's next? Other than that, we've been focusing a lot on performance lately. I'm pretty sure that every single talk you'll hear today is going to mention performance at least twice. So let me say it again, performance. In terms of layout performance or performance of our layout system, it's actually pretty hard to understand exactly what is slow and what is not. Layout is generally a pretty small part of the total time that it takes to load a page. And most of our tests are either micro benchmarks or full page tests. So understanding exactly where the time is spent in layout is pretty tricky. So we have our micro benchmarks and we understand pretty well where time is spent there. For more real world like pages, it's much, much harder, especially since layout can be many, many different things. Are we talking about the initial page layout? Or are we talking about the incremental layout when you make a slight change, or even the layout triggered by an animation? And obviously the performance story for those are very, very different, and also the requirements. So we've been trying to do a lot of profiling to understand exactly what types of layout happens when. Is this really a problem? What things should we focus on? And what is attributing to or contributing to jankiness? Now, using profiling to do this is great, but it's not really sustainable, and it's not something we can expect web developers to do. So we've been doing a lot of work on something we call Layout Analyzer, which basically adds in-depth layout performance tracking to tracing. So you can see that during this animation, these 4 things changed. This triggered a layout of this kind that took this long. And that allows you to reason about different types of layouts and also the different requirements that those may have. This is something that we're actively working on right now, and there are gonna be talks about it later, not here at BlinkOn because it's not quite ready for that yet, but we'll send out more communication about this and look forward to a presentation on that in 6 months. The other thing besides performance we've been focusing on is code health. Like, that's one of the key reasons we're doing these sub-teams, to really, really focus on improving our code health, paying down technical debt, and making sure that we are improving the hackability of the platform and ensuring that we can do new features and new performance optimizations. So some of the major tasks we've been doing in the last 6 months or so is around that. We have the majority of the team working on these type of code health issues. So something I'm pretty sure all of you have noticed is that we no longer have a render object or a rendering directory. It's now called the layout directory, and we have layout objects instead. Now, this wasn't just a simple rename. Instead, we went through every renderer or layout object and every class, trying to figure out exactly what does this do. Before, we had renderers and rendering, which was a very overloaded term. Sometimes it was related to painting validation. Other times it was to do with style resolutions. So we tried to better define that and separate out layouts in a more sort of well-defined way. So this was a massive undertaking. It took many, many, many months, but it's finally done, and we are in a much better state now where we can reason about things a little bit more in isolation. There's still more work to be done to come up with a clearer interface between the two, but we're on the right track, and we're not going to move any more code, at least not for now. As a part of that, one of the major pieces we did was merge render widget, which was one of those legacy classes, into render part, and that allowed us to get rid of a lot of code and complexity. So not only did we refactor, rename things, we also simplified in every single instance we could. And this has resulted in quite a bit of a reduction in the number of lines of code and also in the complexity. And on that note, we've also had a major undertaking to try to eliminate all the cases where we modify the layout tree during a layout. So before, we've had a couple of things like first letter and list items where during layout we actually mutate the render tree, and that broke one of the contracts and made it much harder to optimize or even reason about layout. We're now in a state where We no longer do that for the majority of layouts. There are still a couple of edge cases, mostly around editing, where we do this, but work is underway to completely get rid of all the cases where we modify the layout tree during layout. Instead, there's now an extra optional path just before layout where we do those sort of things. And tying all of that together, now that we have a slightly more sane layout tree, we also invested quite a bit of effort into making life easier for Blink developers to debug these things. So we have this thing called show layout tree, which is a text representation of the layout tree. You can see this quite often in our layout tests, but also when you debug, you can call the show layout tree method, and it just dumps a text representation of the entire tree. It's very useful when you debug things because they tell you basically all the things you need to know about layout. Historically, we've been very worried to change the format of this because every time you do, you have to rebase something like 30,000 tests, which is really, really annoying. So there have been a lot of logic in that implementation to try to mask improvements and changes so we don't have the updated tests. But finally, we bit the bullet. We updated it to actually represent the tree that we use internally and pay the cost of updating all those tests. So that should make debugging quite a bit easier. Continuing on code health, some of the other major improvements we've done in that space, again, ties in with trying to clean up the platform, how to be better defined and more coherent. A major thing we recently did was change our first letter implementation to actually be a pseudo element instead of relying on magic as it did before. Like, there's still quite a bit of magic in there, but you gotta have some magic, right? Something that's not quite done yet is updating our line layout implementation to switch to layout units. And if you're not familiar with layout units, it's a unit we introduced a couple of years ago. It's basically a fixed point implementation that represents 1/64th of a pixel. This is a CSS pixel. And the reason we have this instead of using floating point is to ensure consistent rounding. So this is the data type that we use for all block layout. And we added this to support high DPI back in the day. However, line layout and text layout has historically been done in floating point, because floating point is what you get back from the font system, and floating point is what you speak to the OS when you draw text. So the boundary between block layout and line layout has had all these sort of weird hacks to convert between the two systems. And this has resulted in a lot of bugs over the years, especially when it comes to line wrapping. So each time we cross that boundary, we need to convert the unit, and that introduces rounding errors, which cause things like text to wrap prematurely or overflow the bounding box. It can cause things like incorrect paint invalidation rectangles, so you leave garbage on the screen. It's a big mess. Moving this over to use layout units at the boundary layer between the two will allow us to reason about it in the same coordinate space, if you will. It could also theoretically reduce the number of type conversions, which could have a performance impact. But we're doing this predominantly to have a more well-defined API using a single unit instead of multiple ones. So this work is ongoing. Stefan has been driving it, and hopefully we'll have it ready in a week or two. And the final code health thing I want to emphasize is the work to unify and update our scrolling code to be more sane. Like, we call this root layer scrolling, but it involves a lot more. So traditionally, we've had multiple scrolling implementations that have been mostly, but not entirely compatible. So every time you update it, you have to make sure you update all of them, or you don't get hardware acceleration on one of them, or there are slightly different subtleties that make it really, really hard to reason about it. So this is another major undertaking that doesn't sound very exciting, but it's a big deal and will really help us going forward. So Steve has been working on this, and we hope to have this ready pretty soon. Of course, I'm going to talk a little bit about text. I've already mentioned vertical text. So basically what we did there was, instead of having a special case handling for our vertical text, where we basically rotated each glyph as we laid it out, we now send all vertical text down the complex text path. So when we first tried to make this switch, early last fall, we thought we were golden. Like, text quality improved radically for vertical text. However, there were quite a bit of a performance penalty because the complex text path has historically been between 7 and 13 times slower than the fast one, and a 13x regression actually is noticeable. Shocking. But through the tireless work of many, we were able to optimize the complex text path for vertical text. So it's now faster than the old simple one. And we finally were able to launch the vertical text improvements earlier this year. So not only did we vastly improve text rendering quality for vertical text, we also made it faster. Other work in the text space we work on comes down to refactoring and trying to sanitize the code, if you will. We've done a lot of work to clean up text iterator, how we iterate over text. When we started this process last year, we had 17 different ways to iterate over text. 17. I think we're down to 7 now, and we have a plan to bring that down to 2. So that work, again, makes the code a lot more easy to reason about, allows us to do optimizations once, and reduces the complexity and the size of our code. There's still a lot of work to be done there. We still do a lot of work multiple times. For instance, during line layout, we measure text 3 times. First, to compute the preferred width. Secondly, to actually lay out the text and construct the line boxes. And then do line wrapping based on that. And then a third time, just before we paint it, to ensure we have the proper balance. Now, this is rather excessive, especially since we're guaranteed to get the same result each individual time. So you would think that we could either share the implementation or cache it more aggressively. So that is something we're looking at, and that should have a pretty big performance impact. We think we can improve the text rendering speed by at least a factor of 2 based on that. And it also ties in very well with some of the text blob work we've been doing over the last year, where we basically have the same data structure for drawing text in Blink as we do in Skia, so we just send the binary data over the wire. And lastly, complex text performance. I mentioned a little earlier that we've been working on improving the performance of complex text, and it's no longer 13x slower. We're now down to 2x slower in the worst case, and about 15% faster than simple text in the best case. So that's super exciting, and work that we will continue to do. Now some pre-graphs. So line layout is basically when we lay out inline boxes and text, and it accounts for the majority of layout time on most web pages. Be that text-heavy pages like Wikipedia or the New York Times, or even modern web applications like Gmail or Facebook. For all of them, line layout is the majority of the time for layout. Now, it's a very complex process, and there's a lot of edge cases. We have to handle things like margins and floats and inline images and vertical text and text rendering modes. So it's really rather complicated, but we're making slow and steady progress to improve the performance. So in the last year or so, we've improved performance by about 10% across the board. And that work is continuing. It's not always obvious if something will improve it or not. We've tried a couple of times, as you can see, to implement new things that we think will make it faster, which turns out in some cases it actually does not. So some of the dips here are attempts at performance improvements that backfired. If we talk about complex text, though, in this case Arabic, but it also applies to basically any non-Latin or non-left to right language, the performance improvements are way more drastic. The big bump here in the middle was our attempt last year to just cache the results between runs, and that doubled performance overnight, but it turns out it didn't quite work. There were a couple of edge cases we got wrong, so we had to revert that. And instead, we invested the time to properly profile, come up with good test cases, and figure out exactly where time was spent. and we were able to improve the performance by a factor of 3 without adding any more caching. So that is super exciting. And that again ties into much of the performance and layout analyzer work I was talking about earlier. Through all of this, though, it's not just performance we care about. We also are really committed to code health. And I showed an earlier version of this chart last year at BlinkOn. This is the number of lines of code we have for our font rendering on text rendering. The blue line represents the amount of shared code across all platforms, and the red line, the platform-specific code. That is Windows, Mac, Linux, Android, and so forth. And even though we keep adding capabilities and keep improving performance, we still see our line count drop because we reduce the complexity and we try to have a more coherent, more well-designed system. Now, the font platform code is great in that it's very well isolated, so it's really easy to track metrics like this. If we extend this to the layout code, we actually see a similar trend. Even though we keep adding capabilities and keep adding new features, we see that the amount of code we have keeps going down. So for layout, we see about a 1 to 2% drop per year, and that's been going back the last 2 to 3 years. And that is super exciting. So what's next? Obviously, we're going to continue the very strong focus on code health. We're going to continue with a very strong focus on performance. But there are a couple of key things that I do want to point out. So we're investing pretty heavily in modernizing our layout implementation and trying to come up with a better, more well-defined API and a more coherent worldview. Much of this is driven by our desire to implement support for custom layouts, or Houdini, as I'm sure you'll hear more about later today. So instead of trying to bolt that onto the side, we're trying to come up with a model where we can reason about it and where we can explain custom layouts based on a set of primitives that we also use internally. So this is still at the very early design stages. It's something we're trying to figure out. We know roughly what we want to do, but we have no idea how to get there yet. But it's really exciting, and we have a lot of momentum going in there. We also want to do very similar things to line layout. And some of this is being driven, again, by allowing us to do custom line layout, but also things like text metrics. Like if we're going to expose a text metrics and a line breaking API to the open web, we might as well use it internally as well. And if it's not good enough for us to use internally, then it's probably not the right API to expose to the web. So that's basically the idea there. There's also some individual large tasks that sort of fit into the whole cleanup strategy. One of the more prominent ones there is to kill deprecated paint layer. And deprecated paint layer is the artist formerly known as render layer. And it's this dumping ground where we basically took everything that didn't fit anywhere else and we added it there. We've been slowly removing features and functionality from it over the last couple of years. And this year, we hope to finally be able to kill it and remove it entirely, which would be great. I've already mentioned text metrics, but we also want to support element.measure, which is a measure API that allows you to measure elements without adding them to the DOM or without adding them to the active document. This is something that's really important for complex web apps that want to do some form of custom layout or want to know the size of an element before they add it to the page so they can reserve space for it and have the page be less janky and not having to do multiple layouts as you insert things into a document. I've talked about complex and simple text a little bit earlier. Our plan this year is to completely remove the simple text path. Obviously, we can only do that if we first make the complex path as fast as the simple one, because we do not want to regress performance. We have a plan for this and are pretty confident that we can do it. And I even think that we can get the complex path to be faster than the simple one. So this does not only allow us to simplify our code and have a single text rendering implementation, it also will improve typography support, given that our complex path supports things like kerning and ligatures. So it'll improve text rendering quality everywhere and make it faster. And that's it. So that's our focus for this year. basically continue focusing on performance, and code health. There are certain capabilities that we might do even though it doesn't fit into that. But when we do feature work and capability work, we want to ensure that we're doing that in such a way that it does not increase our technical debt, and that it's built upon the layout primitives that we want to support going forward. If there are any questions, I'll happily answer them now. And if not, you may reach out to layout-dev@chromium.org.
Don't have any questions for Emil?
Excellent. Thank you, everyone.